Welcome to our comprehensive breakdown of the artificial intelligence audit lifecycle. Today, we will explore every single phase an auditor must navigate when evaluating a high-risk automated system. Understanding this full pipeline is absolutely essential for your career. If your enterprise decides to implement an automated tool for high-stakes decisions, you will know exactly how to structure the investigation to ensure it is legally compliant and ethically sound. You can use this exact blueprint to evaluate any vendor software before your company signs a contract or puts customer data at risk. The first phase is scoping. This means defining exactly what you will evaluate and, just as importantly, what you will ignore. Think of it like drawing the property lines before building a fence, because you need to know where your jurisdiction ends. For our lesson, imagine auditing a system used by a hospital to automatically approve or deny patient treatment claims. During scoping, we identify the specific algorithms making the screening decisions. We pinpoint every single data source, such as medical histories, intake forms, and physician notes. We map out the exact logic the system uses to evaluate a case over time. We also define the regulatory boundaries, meaning we list all the civil rights guidelines and emerging artificial intelligence laws the system must obey. The second phase is data collection. Before we test the software, we must scrutinize the information it was taught with. If you teach a child using a textbook full of lies, the child will fail the test. The exact same logic applies to software. We gather the historical datasets used for training, such as past hospital approvals, patient demographics, and protected categories like race or age. We verify this information is complete, diverse, and error-free by comparing a sample against actual medical records. We inquire about the results of any previous data management assessments. Crucially, we investigate privacy controls to confirm that the original patients gave legal consent for their personal information to be used for machine learning. Next, we have the model assessment phase. This is where we open up the hood and evaluate how the mathematical engine was actually built and trained. We ask the developers to explain their design process and how data flows through the system. We look at the architecture, which is simply the structural design of the software. It might use decision trees, which are essentially massive automated flowcharts, or neural networks, which are complex webs designed to mimic human brain cells. We also evaluate the documentation for hyperparameters. A hyperparameter is just a dial or setting adjusted by a human programmer before the machine starts learning, similar to setting the temperature on an oven before baking. We review performance metrics like accuracy rates. You will often see metrics like the F1 score, which is a mathematical calculation used to balance precision and recall, ensuring the system does not just blindly deny every patient to minimize risk. We must specifically ask the developers why these exact targets were chosen to represent success. The fourth phase is the bias and fairness assessment. We must ensure the system treats all groups of people equally and does not illegally discriminate. Imagine a toll booth that charges red cars double the price of blue cars for no logical reason. We are looking for that exact kind of unfairness in the software logic. We asked the engineering team how they embedded ethical considerations into their daily workflows. We scrutinized the output to detect disparities tied to protected characteristics. For example, if we find that treatment claims from patients over the age of 60 are denied 70% of the time, while they only make up 30% of the applicant pool, we have identified a massive red flag indicating a biased system. Phase 5 focuses on transparency and explainability. We must be able to understand and communicate exactly how the software arrived at a specific conclusion. Like a math teacher demanding that students show their work on a test rather than just writing down the final answer, we demand the system shows its logical steps. We review the documentation to ensure it provides clear insights into the decision-making process. If a patient was recommended for immediate surgery because of a specific risk score or vital sign history, we must verify that those specific deciding criteria are plainly communicated to the human doctors using the tool. The sixth phase is the compliance assessment. This is our strict legal verification to ensure the system breaks no laws or mandated obligations. We verify that all personal data is processed lawfully, transparently, and only for the exact purpose the user agreed to. We must investigate where the software physically resides. Is it running locally on an isolated workstation in the hospital basement, or is it hosted globally and accessible via the open internet? If it is global, we must ensure it complies with extra jurisdictional mandates, meaning the regulations of other countries that apply when data crosses international borders. Phase 7 is the performance and outcome assessment. We need to see if the system actually works well in the real world over a long period of time. You cannot judge the reliability of a car by driving it once around the block. You have to see how it performs over thousands of miles. We verify that the model consistently produces acceptable outcomes. We compare its real-world success against the old manual way of doing things. For example, we might measure if the patients approved by the automated system have better recovery rates after 1 year compared to patients evaluated strictly by human administrators. If this software is built for a company to use internally, this step might be blended into the earlier model assessment phase. However, if the company plans to sell or license this software commercially, this long-term outcome tracking becomes an entirely separate and mandatory phase. The 8th step is reporting. This is where we formally document absolutely everything we discovered during the investigation. The final audit report details the initial scope, the objectives, and the legal requirements. It explicitly lists every identified bias, compliance gap, ethical defect, accountability concern, and performance issue. Crucially, it must include actionable recommendations, like instructing the team to retrain the software with a more diverse dataset to eliminate the bias we found. Finally, we must obtain formal agreement and ownership from senior management regarding these findings. The final step is remediation and monitoring. Identifying the problems is useless if no one actually fixes them. The recommendations from our report become mandatory tasks assigned to management. A dedicated tracking application or mechanism must be used to oversee these actions. This tracking process should be controlled by an appropriate and independent group, like the Risk Management Department or the Internal Audit Team. They will track the progress until every single issue is resolved and report the final status to the key stakeholders. Let us summarize this comprehensive process. We establish boundaries during scoping, verify the inputs during data collection, and inspect the internal mechanics during the model assessment. We check for equality during the fairness review, demand clear logic during the explainability phase, and ensure legal adherence through the compliance check. We monitor long-term outcomes, formally document our findings in a report, and track the corrective actions until completion. To ensure you have fully internalized these audit phases, please head over to RooCloud.com. All the critical concepts from this lesson are tested in the multiple choice questions there. You should ideally solve the chapter-wise questions to solidify your knowledge before advancing to the next session. Keep up the excellent work, and I will see you in the next episode.